Hello grade 11 STEM students. In this video recorded lesson, I will be discussing three topics. So in order for you to fully understand everything, please listen carefully. And I am sorry for the background noises. So let's start. When doing a research study, we need to gather useful information from a large group of individuals or objects. Am I right? Yes, and in doing so, it involves a great deal of time and is also costly. Sometimes it is even impossible to collect data from the research population that is too large. So, how can we avoid the circumstances of gathering data from a large group of people, such as time consuming, costly, and etc.? So, to avoid this, researchers resort to sampling techniques, meaning to say, we can get representative sample from the entire population. So, before we proceed to the said sampling techniques, let's first widen your knowledge about these two certain words, population and sample. So, which among the two circle of people is population? Is it the bigger circle or the smaller? When your answer is the bigger one, then you are correct. In statistics, population refers to the whole group under study or investigation. Meaning to say, it is the entirety of the whole group of people. It is a set of all possible values of variable. While sample, it is a subset of the entire population. It consists of one or more data drawn from the population. So kapag sinabi natin sample, ito yung kinuha natin dito sa population. So siya yung magiging representative sample to your research. So instead of doing an interview or survey to the large group of people, you are only going to interview the representative sample. So for our first topic is random sampling. What do we mean when we say random sampling? It is a sampling method of choosing a sample denoted by the small n derived from the population denoted by the capital N, wherein every sample has an equal chance of being selected using the appropriate sampling technique. So for example, when a teacher randomly picks an index card with the student's name written on it in order to know who she will call for the recitation. So, wala siyang sinunod na method kung sino yung pipiliin niyang magre-recite. She just randomly picks as an index card without knowing whose name is written on it. Another example, in a raffle, they write the names of the people who joined in a piece of paper. They will put the papers in a box or glass, and with eyes closed or without looking on it, they draw who wins the raffle prizes. So they randomly picks who is the winner for the raffle prizes. Another one is the wheels of names. Are you familiar with this? Have you ever used this one? Or if not, I will show you how it is done. So, for example, during online class and there are no students participating in recitation, the teacher will decide to use the wheels of name to randomly choose who will recite. So, you're just going to put the names of students here and then you click to spin or press Control Enter. So, this is how we do it. Okay, these are randomly picked who will she is randomly selected to be the one to recite. Now let's move on to the four types of random sampling. So for the first one is the simple random sampling. It is selecting a sample of size from a population of size n, and every element of the population has an equal chance of being chosen to be part of the sample. So in this sampling technique, you can use tools like random number generators or lottery method. So this is the most basic sampling technique since there are no rules to dictate how you will choose your sample. So in the given figure below, this is the population and it consists of 12 members. So yung sample is nakuha by randomly selecting a representative from the population. So in this one, 2, 8, and 10 are the chosen members of the population to be part of the sample. So for better understanding, let's have here an example. So you want to select a simple random sample of 30 employees of company X wherein there are 100 employees in the company. So paano natin gagawin ito? Using the lottery method, you assign a number to every employee in the company database from 1 to 100. So meaning to say, each employee should should be assigned with a number. Then write the numbers on a pieces of paper with the same size and shape. Fold the pieces of paper, then put all the folded pieces of paper in a ball or box. Then, without looking, you should randomly pick out 30 folded pieces from the ball or box. Then those 30 pieces of paper you picked will be your sample. Another example, a researcher wants to study the effects of social media on grade 11 students in University of Northern Philippines. Assuming that there are 1,000 grade 11 students and he wishes to use the simple random sampling technique in choosing his sample consisting 100 members. So using the lottery method, you should have a list of the students' name under grade 11 students. Then you assign a number to each student from 1 to 1,000. Write the numbers on pieces of paper with the same size and shape. Again, then fold the pieces of paper. Put all the folded pieces of paper in a box. Then without looking, you again randomly pick out 100 folded pieces since you want to choose a sample of 100 members. Then those 100 pieces of paper you picked will be your sample. So kung kanino na-assign yung 1, if 1 is picked from the among the folded pieces of paper, then yung pangalan na naka-assign sa number 1 is included in your sample. So we have here another example. A survey on the satisfaction of homeowners living in a certain subdivision with the security features in their place is to be conducted. If there are 1,000 homeowners and you want a sample of 100 homeowners, you can draw for this survey using a random number generator available in the internet. So this is a random number generator. So you go to this link, you can see this one. So since we want a 100 homeowners, we enter 100 in this box beside the question how many random numbers. Then for the minimum value, we enter 1. For the maximum value, we enter 1,000 since there are 1,000 homeowners. Then let's click the calculate button. Now the 100 random numbers will be seen at the below the calculate button. So meaning to say, the numbers assigned to this meaning to say the names assigned to these numbers will be part of the sample that will be used to determine the homeowners who will participate in the survey. So that's it for the simple random sampling. Now let's move on for the systematic sampling. So it is done by listing all the elements in the population and selecting every kth element in your population list. So systematic sampling is selecting such as every third element in the population. So for the given figure, this is our population and it consists of 12 members. So nag-start tayo sa second second representative. So sabi niya every third element. So starting from 2, the next sample to be included in the sample would be first, second, third. So the third one is 5. So 5 will be included in our sample. Then starting again from 5, we get the third, first, second, third. Then 8 is the third one, so 8 is also included in the sample. Next, first, second, third. Then 11 is also included in the sample. So in this figure, the samples included are 2, 5, 8, and 11. We use the third element in the population to choose who will be included in the sample. So for better understanding, let's have again an example. But before that, let's look at this formula, which is used to determine the interval to be used in identifying the samples to who will participate in the study. So K is the sample interval, the capital letter N is the population size, and the small letter n is the sample size. So here is an example. You want a survey of 330 senior high school STEM students who are fond of watching K-drama in your school. How will you select a sample of 70 students by using the systematic sampling technique? So step 1, prepare a sampling frame by randomly arranging the 330 students. Ngayon, step 2, assign each student a number from 1 to 330. So step 3, find the sampling interval or the K, then divide the population size by the sample size. So K is equal to population size divided by the sample size. So since our population is 330 senior high school STEM students, then 330 will be our numerator. Then our sample size is 70 students. So denominator natin is 70. Then 330 divided by 70, that is 4.71 or 5. So 5 will be our sampling interval or K. And then step 4, select a number from the whole numbers between 0 and k plus 1 by simple random technique. So the numbers that are between 0 and k plus 1 are 1, 2, 3, 4, and 5. Since 0 and then k plus 1 is 5 plus 1, that's 6. So the numbers that are between 0 and 6 are 1, 2, 3, 4, and 5. So this chosen value is called the random start. For the step 5, assume that the randomly selected number is 2. Then use 2 as the starting number. So Paano natin nakuha yung 2 as the starting number? Randomly select lang tayo numbers between 0 and k plus 1. For the step 6, select every fifth student from the sampling frame starting the second student. We used every fifth student since we have sample well. So in here, we start the second student, and then first, second, third, fourth, fifth. Then we get the 7, and then first, second, third, fourth, fifth. Then 12 is also included in the sample. So if we keep on getting the fifth student, and we will get the number in the list will be included in the sample are 2, 7, 12, 17, 22, and so on until you reach a sample of 70 students. For example, number 2, if we want to draw a 375 sample from a population of 6,000, we can select every 16th person in the list. So dito is given na yung sampling interval natin, which is 16th. So the sample will be 1, then 17, 33, and 49. Take note that if we use this technique, now let's move on to the third type of random sampling, which is the stratified sampling. To use this sampling method, you divide the population into subgroups called strata based on the relevant characteristics like gender, age range, income bracket, or job role. So based on the overall proportions of the population, you calculate how many people should be sampled from each group. Then you use random or systematic sampling to select a sample from each group. So here is an example. You want to interview 100 employees in a company for your research study. How are you going to choose your sample by using stratified sampling if there are 1,000 employees? So we have said that stratified sampling, we divide the population into subgroups or strata. So our population is the 1,000 employees. This is our population. Now we divide this based on gender. So we have assuming that for the female employees we have 800, and for the male employees we have 200. So this group and this group is what we call the strata. Next, to obtain the sample size of male and female employees, we divide the total number of employees based on gender by the total number of employees in company, and then multiply the result by target sample size of 100. So this is our formula. So we start with the so the total number of employees based on gender for the female is 800, and divide it by the total number of employees in a company, which is 1,000. Then we multiply it by 100. So we get the total of 80 employees. Now for the male employees naman, the total number of employees based on gender under the male employees is 200. And then we divide it by 1,000, which is the total number of employees in the company, then multiply it by 100. Then this is equal to 20. Meaning to say, we get a sample of 20 members from the population of the male. And then we get an 80 sample from the population of female. So 20 plus 50, we get the 100 members of the sample. Another example, you want to interview 200 students in your school to determine their opinion on the new school uniform. How are you going to choose your sample by using stratified sampling if there are 6,000 students? So it is already given the subgroups or strata, which is 1,200 students in grade 7, 1,100 in grade 8, 1,050 in grade 9, 940 in grade 10, 900 in grade 11, and 810 in grade 12. So our population is 6,000 students. And then we divide it by several strata. So for the grade 7, we have 1,200 students. For the grade 8, we have 1,100 students. For the grade 9, we have 1,000 students. Then we have 940. For the grade 11, we have 900. And for the grade 12, we have 810. So these are the code track. Now in order for us to know the sample in each strata, the total numbers of students per year level divided by the total number of students in school. So let's start with grade 7. The total number of students in grade 7 is 1,200. Divide it by the total number of students in school, which is 6,000. Then we multiply it by 200, equal to 40. Next, grade 8. We have 1,100 students. Then divided by the total number of students in school, 1,000 times 200, and it gives us an answer of 7 or 37. Now for grade 9, we have a total number of students in grade 9, which is 1,050, divided by the total number of students in school, which is 6,000. Then multiply 200, and we get 35. For grade we have the total number of students in grade 10, which is 940, divided by 6,000 times 200, and we get 31.333 or 31. And for grade 11, we have a total number of students in grade 11, which is 900 divided by 6,000, and then multiply it will be equal to 32. We have a 810 students in grade 12 divided by 6,000 times 100, which will equal to 7. So, meaning to say, get a sample from grade 7, which is equal to 40. From grade 8, we get a sample of 37. In grade 9, we get a sample of 35. Grade 10, a sample of 31. Grade 11, a sample of 30. And grade 12, a sample of 27, which will be equal to 5. So that is how we get the sample for our interview in the school. Another example is here. Marcella is a statistics student, wants to determine who care more about their physical appearances, the male or the female students. She wants to limit her study to the grade 10 students. There are unequal numbers of students, so 340 are male and 500 are female. She wants her sample to consist only of 50 students. She chooses the members of her sample using stratified sampling. So in this example, na-subdivide na yung population natin into two strata based on gender, which is the male and female. So since there are 340 male and 500 male, then it means that we have 840 students as the population. Then the strata will be 340 for the male and 500 from the female. Now, to solve for the sample in each gender, we use the formula total number of students per gender over total number of grade 10 students. So for the male students, we have 340 divided by 840 times 50. And we get 20.2420. Now for the female, we have 500 divided by 840 times 50. So we get 209.7430. So it means that the number of the sample we need to get from the male is 20 and the female is 30, which will be equal to 10. For the last type is the cluster sampling. It is a random sampling wherein the entire population is broken into small groups or clusters, and then some of the clusters are randomly selected. The data from the randomly selected clusters are the ones that are analyzed. So generally, first sampling is performed at higher levels before going down to lower levels. So here is an example. A researcher wants to determine who among the families in a small town are using the detergent product. How is she going to do this using cluster sampling technique? So first, divide the population into clusters. Use barangays as clusters. For example, for the small town of San Vicente, there are 6 barangays. So we divide the town of San Vicente into 6 barangays, which are Barangay Bantaway, Pudok, Poblacion, Bong, San Sebastian, and Bayubay. Since not all the barangays of the town will be included in the sample, we're just going to choose the final barangays by either using the simple random sampling or systematic sampling. So in here, assuming that we want to use the systematic sampling, so starting from 1, then we get every second barangay. So first, second, and then first, second. It means that Barangay Bantaway, Poblacion, and San Sebastian will be included in the final barangays. Now, not all the families in each selected barangay will be included in the study since not all the families are using detergent product. So we're just going to select the final families to be included in the sample by either again using a simple random sampling or systematic random sampling technique. Then the selected families at Barangay Bantaway, Poblacion, and San Sebastian will be the final sample for the research. So those are the 4 types of random sampling. First, simple random sampling. Second, systematic sampling. Third, stratified sampling. And lastly, cluster sampling. Now let's move on to the next topic, which is the parameter and statistic. So study the cases presented. Identify which of the cases involves measures from a population and a sample. So for case 1, it states that a researcher randomly selected a sample of 1,000 people in Barangay 143 and asked if they used a certain coffee product, and 40% said yes. And for the case, now let's move on to the second topic, which is parameter and statistic. So there are two cases presented. Identify which of the cases involves measures from a population and a sample. So from case 1, it states that a researcher randomly selected a sample of 1,000 people in Barangay 143 and asked if they use a certain product, and 40% said yes. The case, a researcher interviewed all the students in a certain school to identify their insights about their favorite shoe brand. So for the first case, um, the researcher measures for a sample because only 40% out of the 1,000 people in Barangay 143 said yes. Now, in the second case, um, it measures the population since the researcher interviewed all the students. So the whole group of the population was interviewed. In this case, for case 1 is um, it measures the sample. It measures for a sample, then um, it is an example of statistic. And for case 2, since it measures for a population, that then it is a parameter. So a parameter describes a population. It is a measure of the characteristics of the entire population based on all the elements within that population. So we have here an example. The researcher interviewed all the students of a school for their favorite apparel brand. So since the researcher interviewed all the students, then it means that it is an example of parameter since it describes a population. Now, a statistic, it describes a sample. It can be calculated and observed directly. The statistic is a characteristic of population or sample group. So, for example, 50% of people living in the US agree with the latest healthcare proposal. So, it is an example of a statistic because it only describes 50% of people living in US. So, for our keyword for parameter is the word all, since it describes a population. Now let's try to determine whether the given examples is a parameter or a statistic. So for the first one, average income of all faculty members working at CTE. So it is a parameter since it describes the population, all faculty members. For the second one, average income of faculty members of mathematics department. It is an example of statistics since it only describes the faculty members in mathematics department. For the third one, a recent survey of 40 students reported that the average weekly income for students is 17,000. So it is an example of statistics since there are only for 50 college students that are being surveyed. Now, for one, average weekly income for all students in 20 is 21,000. So, it is an example of parameter since it describes the population for all students. And lastly, 30% of dog owners poop scoop after their dog. And it is an example of a statistic since it is only 30% of dog owners. So let's move on to the last topic, sampling distribution of sample mean. What is sampling distribution of sample mean? It is a frequency distribution using the means computed from all possible random samples of a specific size taken from a population. For example, a population consists of the five numbers 2, 3, 6, 10, and 12. Consider samples of size 2 that can be drawn from this population. So for step 1, note the number of possible samples that can be drawn from the population. So using the combination, it is a way to calculate events where order does not matter. So we use the formula for combination, which is the population combination sample, which is equal to population or n factorial over the sample or the small n factorial times the population minus sample, then factorial. So since our population is 5 and since our population is 5 because we have 5 numbers 1, 3, 4, and 5. Then our sample size is 2, which is given. And then 5 factorial over 2 factorial times 5 minus 2 factorial, that would be 5 factorial over 2 factorial times 3 factorial. So for if we say 5 factorial, it means that you multiply up down to 1. So 5 times 4 times 3 times 2 times 1 over 2 factorial, then 2 times 1, 3 factorial, 3 times 2 times 1. So 120 divided by 2 times 6, 120 divided by 12, then we have 10. It means that there are 10 possible samples to be drawn. So for step 2, construct the sampling distribution of sample means. List all the possible outcome and get the mean of every sample. So paano natin nakuha yung sample? It is to starting from 2, we 2 and then 2 and 6, 2 and 10, 2 and 12. Dala-dalawa lang since ang sample natin is 2. Then, after ng 2, we proceed to 3, 3 and 6, 3 and 12. Then, after that, we proceed to 6, 6 and 10, 6 and 12. Then, 10, 12. So, we have 10 possible outcomes. Now, we get the mean of every sample. So, how did we get the sample mean? We add 2 plus 3, that is 5 divided by 2, that is 2.5. 2 plus 6 divided by 2, that's 4. 2 plus 10 divided by 2, that's 6. 2 plus 12 divided by 2 is equal to 7. 3 plus 6 divided by 2 equals 4.5. 3 plus 10 divided by 2, 6.5. 3 plus 12 divided by 2, 7.5. 6 plus 10 divided by 2, 8. 6 plus 12 divided by 2, 9. 10 plus 12 divided by 2 is equal to 11. So for step 3, make a probability distribution of the sample means. And this probability distribution is called the sampling distribution of the sample mean. So since we can see here that sample mean 2.5 only occurred once, so the frequency is 1, and the probability would be 1 over 10 or 0.1. So 4 also appeared once, so we have a frequency 1, which have probability 1 over 10 or 0.1. So up to the last one, since they only appeared once, we have them all frequency which is equal to 1, and their probability would be 1 over 10, 0.1. And always remember that the probability with all, if you add them, it should be equal to 1. So for the next example, construct a sampling distribution of the sample mean for the set date set of data below. So consider a sample size of 3 can be drawn from a population. So our population is equal to 5 and our sample size is 3. So step 1, know the number of possible samples or outcomes that can be drawn from the population. So the combination of the population and sample, we have 5 factorial over 3 factorial times 5 minus 3 factorial. So 5 factorial over 3 factorial times 2 factorial, that would be 5 times 4 times 3 times 2 is 1 over 3 times 2 times 1 times 2 times 1. So we have 120 divided by 6 times 2, 120 divided by 12, which will be equal to 10. So there are 10 possible samples to be drawn. So for step 2, construct the sampling distribution of the sample means. Then list all the possible outcome and get the. For step 2, construct the sampling distribution of sample means and list all the possible outcome and get the mean of every sample. How do we get the sample? 86, 88, 90. We start here from 86, 88, 90, then 86, 88, 95, 86, 88, 98, then 86, 90, 95, 86, 90, 98, then 86, 95, 98. Now we proceed to 88. So 88, 90, 95, 86, 88, 95, 98, then 90, 95, 98. So for the sample mean, we add 86 plus 88 plus 90 divided by 3, we get 88. Get 88. So for 86 plus 88 plus 95 divided by 3, we get 90. Then 86 plus 88 plus 98 divided by 3, we get 91. Then 86 plus 90 plus 95 divided by 3, we get 90. Then 86 plus 90 plus 98, we get 91. Then 86 plus 95 plus 98, we get 93. 86 plus 95 plus 98 divided by 3, that's 93. Then 88 plus 90 plus 95 divided by 3, we get 91. Then 88 plus 90 plus 98 divided by 3, that's 92. Then 88 plus 95 plus 98 divided by 3, that's 94. And 90 plus 95 plus 98 divided by 3, that's 94. Now for step 3, make a probability distribution of the sample means. So using the sample mean of every sample, we get the probability distribution of sample means. So we can see in the sample mean that 88 appeared once, so the frequency would be 1 and the probability is 1 over 10 or 0.1. And 90, it appeared twice, so 1 and 2. So 90 has a frequency of 2 and a probability 2 over 0.2. Now for 91, it appeared thrice, 3 times, 1, 2, and 3. So it has a frequency 3 and a probability 3 over 10 or 0.3. For and now 93, it appeared only once, so they have a frequency of 1 and a probability 1 over 10 or 0.1. And for 94, it appeared twice, so it has a frequency 2 and probability over 10 or 0.2. So that is all for this video. I hope you have learned something.